Hey everybody, Daniel here from Basement Tech. Hey, I'm feeling a little guilty today for two reasons. One is, you can see I'm back here in the basement working on the CNC Router Monitoring project, which means I didn't fulfill my commitment to you to make my last video, the last one before you see it on the router. I discovered some things down at the shop. I did take the current measuring device down to the shop and discovered some things that I'll tell you about here in a second. Second reason I'm feeling guilty is nobody should get to have this much fun. Wait till I show you what I've been doing here in the basement, and it's just a blast. Stand by. Okay, a few things I learned down at the shop. I took this little board here, which is the INA169 high side current monitoring amplifier, and connected it to the actual shunt down at the shop. I ran some G code, and as you might suspect, the current waveforms are just crazy. The 48 volt power supply is unregulated intentionally so that the electrons can kind of slosh back and forth as the motors are starting and stopping. But with four motors, stepper motors, all responding to the current waveforms that are all pulsing, you can guess there was tons of noise, both plus voltages and a few minus voltages. So I read through the data sheet on this little high side current monitor, and in fact it can be powered. The op amp that's in there can be powered from a separate, much lower voltage power supply. So after doing tons of experimentation, I decided that it would be best to power it from the same 5 volt power supply that I'm powering everything else with. So I added this little distribution panel down here in the bottom, and what I have laid out here is that system all connected together. The astute among you might also notice I kind of built this little board upside down. I forgot that the power supply connection to the shunt is actually on the bottom, and the power coming out to the motors is actually on the top. But I just had to flip a couple wires around and we're all good. And then you also see the power supply wires missing from there, and then you see this twisted black and red pair that goes back to the power supply here. I'll have to do a little system diagram to help you understand what's going on. But let me show you the next cool thing that I was doing here in the basement. Okay, so this little corner is a bit of a mess, but what it actually is just a way to generate millivolts like the shunt would using a 48 volt power supply. So this supply up here has the ability to connect two 25 volt power supplies, adjustable in tandem, in series, to generate, in this case, up to 50 volts. So that's what I have running into the top, the very top, and the very bottom here. The carbon resistors down at the bottom are about 250 ohms, and the two precision resistors up at the top, you might even be able to see, are 0.047. So taking those in series, you get about 0.094. So that generates millivolts in the nice range that we like to simulate what's going on down at the shop. Now, of course, this is way cleaner, but it does give me the chance to make sure everything is working properly. So back over here, do notice that the signal wires, that yellow and green pair, the signal wires coming out of the amplifier go over here to the A to D input that I showed you a couple videos ago, and ultimately into that ESP8266. So 48 volts comes out here. That runs through this series of resistors. The two precision resistors at the top are like the shunt that's actually in the CNC router controller. Via this yellow and green wire, it comes over as millivolts into this input, which will ultimately be screwed directly to the shunt, through this amplifier, which has a gain of about 68, and then tens and hundreds of millivolts up to probably 1.5 or so volts goes over here to the A to D, and the A to D's max voltage is set to be compatible with that input. So ultimately from the A to D to the ESP, from the ESP through all of that software I've showed you earlier, out that little Wi-Fi antenna, and ultimately to the data broker to be viewed by Node-RED locally or anywhere in the world. So I think that's all pretty cool. Okay, so finally a demo. This meter up here is showing millivolts. That's 1.02. This is 199 millivolts full scale. So, and then the scope here is showing the output which starts at 0 there, and you can see it's 200 millivolts per division. Ultimately, it's going to be played out on these LEDs down here. Let me zoom back out. The LEDs here, now I set the full scale to 15. There are 15 LEDs, so each 1 amp that I dial in using that power supply, in other words 1 millivolt, up on that first meter I showed you, should click it up one by one by one on the NeoPixel strand. And remember, the same data is being sent over the network via MQTT to the data broker and ultimately to this node red interface. The time averaged current is being sent once every few seconds. And in the upper right, you can see the meter just going up with the current value. The idea here would be I could view this from a different room, for example, to know if the machine is showing stress. All right, there you have it. Fun in the basement for today. Well, I sincerely hope this is the last one from the basement with this project, and the next one you'll see will have it deployed completely on the CNC router and sending that health and welfare data off to a really, really cool user interface. If you like this kind of video, be sure to give it a thumbs up. If you really, really like these kinds of videos, definitely subscribe. And if you want to be the first kid on the block to see them, click the button that says, please notify me. Thanks. Have a good day. Bye.